Alright, so hello and welcome back to Principles of Engineering. Today we are covering torque. So what exactly is torque? So torque is a force that produces or tends to produce rotation or torsion according to Webster Dictionary. That definition doesn't really tell us a lot. So let's look at an example of torque. So here we have, imagine a seesaw with a force being applied on one end. I'm just going to write in force. So when that force is applied, the whole seesaw doesn't just push down. That's not what happens. What happens is it rotates. One end moves down like that. The other end moves up in a counterclockwise direction. And this happens because it's being supported right here. And this little connection is preventing the whole thing from moving straight down. In this instance, the force is producing a torque. So to understand just a little better, let's look at the equation for what torque is. Torque equals R cross F. So in this case, that weird looking T, it's tau, it's a Greek letter, and it stands for torque. R actually doesn't stand for radius in this equation. It stands for the distance from the fulcrum. And I'll get into just what a fulcrum is in another minute. And F, of course, is force. So the reason we're using an X here and not something else is that the distance from the force and the direction that the force is being applied in have to be perpendicular, meaning they have to be at a 90-degree angle to each other. So if we go back to our example here, you can see that the force is being applied perpendicular to the seesaw. So some of you may or may not know this, but what is a fulcrum? So when we're measuring our distance here, how do we know how long it is? Do we measure from one end of the seesaw all the way to the other? All the way to the other? Do we measure halfway down one end? Well, no. What we measure to is what we call the fulcrum, or the center of rotation, the axis of rotation, sorry. It's the point around which the whole system is rotating, which in this instance is right here in the center. So when we're measuring R, it's the distance from the force to this axis of rotation. And that's how we find our torque. So if this was, I don't know, let's say 2 newtons, I'm going to type this just for legibility's sake. So this was 2 newtons, and the distance was, I don't know, let's say 5 meters. Well, if we look down at our equation, R cross F, we have a R of 5 meters, F of 2 newtons, so we would get a torque of 10 Newton meters. That's very important. The unit for torque is Newton meters. I think that concludes this lesson. Spend a little time trying out some problems related to torque. We'll have a couple on the next page. And just try to get yourself familiar with this topic before moving on, since it will be useful in the next section, which is simple machines. Thank you.